Orange Hue is watching live and just put streaming is harder than learning about stars. This is true. Orange
Yeah.
Hue, I went down a
Yeah.
rabbit hole earlier today and did what is best described as unholy things in Stream Deck that will allow it to now launch all the tabs in the correct in the correct Chrome identities without screwing up anything I already have open, and then launch all of my software. And like I'm ridiculously proud of the thing that I have done.
And you should be. Yes, we can hear you, Adrian. Can we see you? No. No, that's a little creepy. No. Or can we?
Yeah, no. We only see your texts.
We only
That's
see your
it.
text. We are only aware of your existence. So have you started watching Pluribus yet
No, I
on
haven't.
Apple TV? Oh,
Uh-uh.
it's so good. It's so good.
I
Yeah.
I went to see Predator Badlands last
Ooh,
night.
I hear it's no good.
It's if you're expecting a Predator movie, it's no good. If you are just there to eat popcorn, it is weirdly endearing with a
Mm,
side of kaiju.
mm.
And I'm here for anything that involves giant monsters for
Giant monsters. Yeah.
yeah,
Yeah.
yeah.
So no giant monsters in Pluribus. The gist of it is essentially the humanity is taken by a virus that turns everybody on Earth into a hive mind.
Oh.
So everybody on
Oh.
Earth, and this is like Pluribus. This is by Vince Gilligan, who did Breaking Bad, Better Call Saul, and he used to be a writer director on the X-Files.
Oh, that makes sense.
Yeah, yeah. And so this is sort of like a total science fiction, totally different story than Breaking Bad. But so it's the main character from the woman in Better Call Saul, and she is not connected. So she and like 12 other people in the world are not connected to the hive mind. And so they're having to interact with this essentially new organism that has
Mhm.
taken over all of planet Earth. And so, no matter who she talks to, she's talking to them,
Oh,
us,
wow.
and and it's very cool. So yeah, yeah, I highly recommend it.
Okay. I
There are
will.
only 2 episodes in, but it's feeling like the show. Like if you enjoy, like this is way better than Severance, in my opinion. Like
Okay.
way better. Yeah, so far. Yeah. So
Good to know.
yeah.
I'm watching really stupid fantasy flick right now on Netflix. I'm not above doing that.
Mm. What
Yeah,
else did we
it's
watch?
just a witches and vampires and demons kind of movie.
Oh, movie. Okay,
Not
the
movie,
fact that you
TV series. Sorry, it's a TV series.
it's not The
Yes.
Witcher, is it? You're not watching The
No, no,
Witcher.
no, no, no,
Okay,
no.
okay.
I watched the original, but then they went and changed who The Witcher is, and
Hmm.
it
The
became dead
Switcher.
to me.
Why?
I don't know. It just
It's
did.
fine. It's fine. He's fine.
Okay.
Yeah, it's perfectly fine. Yeah.
Okay.
And people are moaning about how woke it is, which makes me want to watch it even harder. So,
All right. So I hadn't
yeah.
heard that, and I now want
Yeah.
to
Oh
watch
yeah,
it.
that's the big complaint. If you go and see, people are complaining that it's too woke. I guess cuz like they've got female sorcerers of different ethnicities. How dare they? So, because
That
everybody
is not a
knows
problem to me.
that the sorcerers were all dudes in The Witcher, and in the accurate historical time when The Witcher took place. So, this
All
is sort of the
right.
same thing about people talking about the Lord of the Rings TV show. It was, they were whining about, African American elves. How dare they? So, no, it's just like it just wasn't a great show. But
Yeah.
having all of this diverse casting is fantastic. I love it.
Yeah. No,
Yeah.
I'm watching Discovery of Witches because I really liked the books and I'm deeply
Mm,
confused by the TV series, but it's something I can put on in the background while doing tasks that
mm,
require not all my brain because
right.
there's like part of my brain that needs fed to something.
Yep.
And being
Yeah.
confused by a show
Yep.
that is the fluffy version of some books I really loved is
Hmm.
is currently where it's at. So
So is
it's
that the one I think I've seen it. The first 3 seasons I think we watched. There's like a new
It's
season that
an
came out.
Oxford
Yes.
professor. Yeah,
Yep.
yeah.
Yeah, we watched it. Yeah. Yeah, it's fine. It's
Yeah,
fine.
it's totally fine.
Mediocre. Yep.
The books are much better, but that is often the case.
Yes. All right, let's get started.
All right. Okay, pressing record on my audio. Hello. Yes, it's actually recording. Pressing record on the video. Everything is recording.
Everything is working.
Yes.
Okay. Astronomy Cast, episode 771, Comet Tales. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. I'm Fraser Cain. I'm the publisher of Universe Today. With me, as always, is Dr. Pamela, a senior scientist for the Planetary Science Institute and the director of Cosmo Quest. Hey, Pamela, how you doing?
I am doing well. I am very envious of the amazing adventure you're about to go on. It sounds so cool.
Yeah, we're going to do a month in Thailand.
So
Not for any purpose, but to escape the Canadian winter.
And we are about to record a bevy of shows. And there's going to be very boring intros because we're just going to sit and do them.
How are you doing? I don't know how I'm doing because we recorded this in advance.
Exactly.
I have to assume that I'm fine. So, yeah. I saw an elephant. I went to a temple. I ate some really tasty Thai food. I don't know. With the arrival of Comet 3I Atlas, the world is getting a crash course on comets, their behavior, and of course, their tails. Today, we're going to talk about comets and their tails, why they exist, how they grow, why they can be different colors, and how they can sometimes point at the sun. And we'll talk about it in a second, but it's time for a break. And we're back. So I've ranted quite a bit on my channel about how awesome Comet 3I Atlas is.
Yes.
And my frustration at the nonsense that is proliferating on YouTube. And there is a lot of nonsense. You know, on the best case, you have people who are writing scientific papers that go against the scientific mainstream and much to the eyebrow raising of their scientific colleagues, not naming any names, pointing any fingers. And on the worst case, you've just got people making stuff up, just literally going, it broke into 17 pieces and now we've got spaceships that are flying out of it and laser beams and people receiving communications. And, you know, it's so, and a lot of it rests on the behavior of its tail.
I know.
So I think today, let's just hammer comet tails until we really, really understand the whole process, and that will give us a lens from which to both understand this comet and every comet that will ever show up again in the future. So I guess, what is a comet tail?
It is material that has been removed by some form of physics from the nucleus of the comet. And the reason I phrased it that way is we have two different processes going on. One is your standard stuff melts, which actually in this case means sublimation. So you have all the volatiles, all the frozen stuff that as it gets energy injected into it, either from solar heating or because there's been landslides or something like that inserted kinetic energy, some form of energy got inserted, and that raised temperatures, caused phase transitions, and now you have stuff that has gone from solid to gas.
Right.
Now, in the process of going from solid to gas, and I'm so sorry for the dog barking, we're going to pause for a moment.
So thanks to Zoom, I don't hear the dog barking at all.
No. There's two of them. It started with Eddie, who knew why he was barking. And now it's Stella, who doesn't know why she's barking.
Right. But if Eddie's barking, she's got to get in on that.
They're now going back and forth. All right. Okay. They seem to have stopped. All right. So you have the phase transition, the gas getting formed. Now, in the process of gas being formed, The solid going to gas is a wild change in volume. And this can eject dust at all sorts of different velocities in all sorts of different directions.
Hmm.
And so you also have dust getting ejected from the comet nucleus. So around your comet, you have expanding gas, you have dust, and all of this stuff can be slightly different colors depending on what's going on.
And so dust, it's very interesting. For a while there, we've always talked about dust
Yeah.
and as this thing.
Yeah.
And I wanted to like get to the bottom of it. And so talked to a bunch of scientists and was like, okay, look, if I could hold some dust in my hand, what would it look like? If I could throw dust up in the air, what would it look like? And the best example is essentially smoke coming from
Yeah.
a fire. That
Yeah.
you've got these, was it polyachromatic carbon
Polycyclic
compounds?
aromatic
Polycyclic aromatic compounds that you've got.
hydrocarbons.
Yeah, hydrocarbons. The soot coming from hydrocarbons that are then mixed in particles of this soot, and these are very small particles, they are micrometers across. They are mixed in with the volatile elements, the frozen nitrogen, the frozen oxygen, frozen carbon dioxide on the surface of this comet. And so then as this gas is sublimating off of the surface, you've also got these PACs, is that right? Yeah. The soot, this dust being wafted
PAHs.
into PAH. That's it, right?
Yeah.
Right. Yeah. You've got this soot being lofted into the environment around the comet as well. And this is going to be important when we sort of come back around to it.
All right. So the way I always think of it is they're just really big molecules. And sometimes they're multiple molecules that have decided to gang up and join forces to build slightly bigger things.
Right. Right.
And this is where it's important to remember they can have different sizes. And sometimes it's not the kind of dust you're talking about, which is like the stuff that lives between the stars, the interstellar space, the dust of why it's really hard to see through clouds of material, the dust that makes the Horse and the Horsehead Nebula. Sometimes dust is just grains of material because comets are made of rocks and ices. And so we get all these different grain sizes. And some of these grains are actually the stuff that's eventually going to form meteor showers. Less exciting than polycyclic aromatic hydrocarbons. Easier to spell and cause really cool light shows.
Yeah. Yeah. I love Nicole did her science experiment at one of I think at DragonCon one year and had dry ice and
made a
bits
comet.
made a comet. Yeah. And all of the raw material, bit of dirt, bit of
Cooking
regular
oil.
ice, dry ice, cooking oil.
Yeah.
Yeah. All of this stuff, mixed it all together and made a ball. And then you watch as the carbon dioxide is sublimating off of the surface of it, and bits and pieces of it are dropping off onto the ground.
Yeah, add a little bit of ammonia in there.
Yeah.
It's really cool.
Yeah.
And so all of this stuff, when you take that dirty snowball that has been going through interplanetary space, interstellar space, it has been gathering on its surface all of the dust. And it's also had very slow chemical reactions going on that form these larger molecules. So as it comes into the solar system, it experiences gravity, which can cause from other objects, which can cause landslides, and it experiences solar heating. Both of these factors can cause activity, which is also why we see centaurs that get active sometimes out beyond Jupiter in the outer solar system. And this kind of activity is going to shed dust.
Right.
And that dust is going to reflect light, and it's going to reflect predominantly redder light because it's really big stuff. So the reflection goes all the way into the reds. And so looking at a lot of comets when they first start to get active in the outer solar system. And 3I Atlas is utterly unsurprising. It's remarkable, but also utterly unsurprising. And it started out by doing the I'm going to be red right now thing.
Mm-hmm.
And yeah, it was awesome.
Right. And so this idea of I mean, what we're talking about here is the coma.
Yes.
And when you look at a comet and you see this diffuse blob in your telescope, that is the coma. The nucleus is down there inside. Sometimes you can't even resolve the nucleus. Sometimes you can, but then around that is the coma. The coma can be hundreds of kilometers across, while the nucleus may just be 5 kilometers or 1 kilometer, and it can just produce enough material that makes this larger, brighter object that you can see. So how does the coma become the tail?
So we have two different processes that we need to keep track of, and a third that occasionally happens that we'll get to. So the tails, there's normally both an ion tail and a dust tail. And the ion tail is rogue molecules, so like C2. I'm not talking the polycyclic aromatic hydrocarbons here. I'm talking like C2, sodium, methane, just the super simple little tiny stuff you can build with Tinker Toys and not hate yourself in the process.
Right.
So that stuff can form ion tails, and the ion tails, as the name implies, are charged. So because they are charged, as the solar wind of high energy particles, as the sun's magnetic field interacts with these charged particles, it forms a tail that is distinctly separate from the dust tail, which is the second tail. And the dust tail tends to be made of bigger stuff. And that bigger stuff has its location influenced by the motion of the comet. So it's leaving stuff behind as it goes. And it's getting pushed by the not charged light of the sun. Photons aren't charged.
But I think it's really important. Like, I think we have this terrestrial in atmosphere concept of, you even said it, leaving stuff behind. But this stuff is coming off of the comet and has the same momentum as the comet itself. Yes. And that if there was no sun, no solar wind, then this diffuse ball would just continue along with the comet. Its gravity would pull it back down onto it, and that would be that. But because the solar wind is interacting with it, it's causing a force against its motion that is pushing it away from the comet. Yes. And so when you see this tail, it's still moving at roughly the same speed as the comet, but a little bit slower and in a little bit different direction. And that's why the tail starts to grow out from the comet as it gets warmer, more activity on its surface, more coma is produced, more of this material gets separated into the ion tail and the regular dust tail. And that's how we see that. And then just the size of the tail will depend on how much radiation this thing has received, how close it is to the sun, and then what its composition is depending on the sublimation temperature. All right, we're going to talk some more about this, but it's time for another break. And we're back. All right, so that's how we get the tail. Now, what about the color of the tail? Because that changes from comet to comet.
Yeah, and it is a function, and it can change over time as different stuff gets revealed. And it's a function of composition. And one of the mistakes that is easy to make is, are aurora colors and comet colors related? Yes and no. It is the same physics, but because it's working in different regimes with different energies involved, we're seeing different reactions. So we see red in comets, we see red in aurora, different causes. The red in comets comes from either scattering off of dust, less exciting, or sometimes, very rarely, we get super lucky and there is sodium in the tail that ends up being really cool, bright, if you have the right filters and you expose long enough, red. So you can get red in the comet tail, and it's not associated with the ion tail. It's associated more with the dust tail towards the ion tail, because it's like its mass puts it in between. I just want to go back to this mass thing again. The reason you get different spreading out of the dust tail is different mass particles get pushed with different efficiency. A low mass particle is going to like totally get flung out by solar light pressure. Heavier mass stuff is like, I'm just going to hang back here. You're not going to push me quite so hard. So it spreads out as a function of mass. And then the ion tail is just like, I am small and narrow. It's the way it works.
Yeah, I mean, it's kind of amazing that the magnetic field of the plasma coming from the sun in the solar wind is grabbing those ions, locking them into place and moving them directly.
Yes.
While the dust tail, it's more of a transfer of momentum from the particles in the solar wind that are bonking into them, as opposed to just that really tight coupling of the electromagnetic field, of the magnetism.
Students are so glad I'm not teaching Physics 1 right now, because this is entirely a case of a object in motion stays in motion until acted upon by another force. And we have two forces acting on all of these things, the electromagnetic force, and then we also have impulse, which is easier to solve as a transfer of momentum problem. From photons. And so the dust, the electromagnetic force, just it's like not as big a thing, even if the dust is charged, because those molecules are so big.
Right.
But the bigger they are, the more light is hitting them and pressing them, but the harder it is to move it. It all balances out. It's an amazing set of just balance the forces and remember the inertia.
Right. But you would require, like, for homework for your students, you would be requiring two different sets of calculations. One is all about the impulse, while the other one is about calculating the magnetic moment
it's the sum of the forces. So you're taking the electromagnetic force and you're taking it's the impulse from getting hit by the photons.
Right.
So you just sum the forces and you do it as a function of these things have this much charge and this much mass. This stuff has this much charge and this much mass. And so I'd have them run the calculations for some random dust grain I pulled out of a textbook. And then for a charged, probably just charged carbon atom.
Right. Yeah. Okay, we're going to talk about this some more, but it's time for another break. And we're back. So let's talk about some sort of strange behaviors that we might see from Comet. So one of the things that was very interesting with Comet 3i Atlas, right at the very beginning, we were super lucky that we detected it early on its way inbound. We didn't get that with Borisov and with Oumuamua.
Right.
Astronomers were able to watch this strange anti-tail, but essentially material that was making its way towards the sun. What was going on there?
So two problems. One was human language, and the other was lots of dust. So what it actually had was a forward-facing plume. But because we're so used to talking about comet tails, people were like, it has a tail facing the sun. That's not a thing, people. So what was happening is you have this chunk of dust-covered ice. The front part facing the sun is heating up in the sunlight. Dust actually helps stuff heat up because it's dark, so it absorbs. And if you have a grain of dust with ice behind it, and that ice gets warm, sublimates. When it sublimates and expands, it's going to fire the dust straight out towards the sun in this case. So the reason there was a plume facing towards the sun is that was dust getting fired off the surface of the sun, not the surface of the sun, the surface of the comet as the comet warmed up and just flung that dust straight off.
Right. And that's the kind of thing that you would expect to see early on before enough light pressure has built up to really start to push that tail back away from it.
Well, more than that, it was just that much dust and heating at that point.
Right.
So once you get all the dust off of it, and that's part of what's happening is they're literally cleaning the surface off.
But right. But all I'm saying is that,
Yeah.
in the beginning, there's not enough light pressure coming from the sun to really produce that long tail. So instead, you get this heating on the side that's facing. It ejects a bunch of dust towards the sun. That's kind of, it's got that initial velocity off of the surface of the comet, and then over time, as it gets closer and closer and closer, then the light pressure of the solar wind starts to pick up and push that stuff away into that proper tail that that we always expect.
Yeah, there's a
So
1 over r squared relationship for those who like math. So basically,
right.
you're far away, there's less sunlight. You get closer in, there's more sunlight per square meter. And so it's literally the closer in you get, the more sunlight is pushing against you. So
So
it's two different factors. But yeah, totally.
So let's talk about how the tail is facing away from the sun. And it makes the comet look like, when it's going towards the sun, it looks like a burning fireball that's on its way towards the sun.
Yeah,
But
it's
when
not.
it's going away from the sun, it appears as if it's going in reverse.
So in general, if you look at a comet from a top-down view of its orbit relative to the sun, you can draw a line from the sun towards the comet, and its tail will arc away from the sun and towards where it came from. And what's happening is, as it moves, sunlight, literally the pressure from the light, is pushing the material away. And as it moves, this part has now been pushed for a longer period of time. This part has been pushed for a longer period of time. So that bit of curvature is reflecting the fact that where it was has now been pushed out. With Comet I3i Atlas, there's actually this really neat case where over time, the tail is going to get pushed out to where Hera and Europa Clipper are now. So potentially, it's not that the missions are going to fly through the comet tail. It's they're continuing their journey, and the sun is pushing the comet tail past them.
Right.
And that's awesome.
Yeah. I mean, if we're unlucky, it'll be about 8 million kilometers away from
Yeah.
Europa Clipper. But if we're lucky, it might actually go right through that tail. And Europa Clipper is equipped with the kinds of tools on board to be able to study the particles if it can get close enough to be able to analyze them. And that is this is a comet that formed in another star system. This is a gift that the universe has sent to us to say, hey, study this.
Uh-huh.
And we happen to have a spacecraft that is perfectly positioned that it might actually be able to study it.
And so, yeah, the sun is pushy, light is pushy, magnetic fields like to move things around.
Yeah.
All of these factors are working at different ways to move things.
So one other thing that's happened, and this happened in 3i Atlas, although this happens regularly, is that the color of the comet has shifted.
Yes.
So you mentioned early on that it started out red and then has recently, or I guess has been brightening and also shifting more into the blue.
Right. So it starts.
And I think people are misunderstanding this because they're
Yeah.
saying, so it was a red comet in the beginning and now it's a
This
blue
is just
comet?
normal. So
Yeah.
it started out shedding dust, all the dust be unto you. Then, as it continued to heat up, we began to see I always have to look at how to say this, diatomic carbon reaction. So what's happening is you have C2 molecules, you hit them with one photon and they go, oh, wait, what's going on here? You hit them with a second photon, they lose an electron. That electron wants to come back, and when it does, it releases a green photon. So this is a really weird reaction because it requires two photons before the molecule decides, oh, green is going to happen now. So carbon molecules in the coma of the comet are getting excited. They shine green. Tail is reflecting sunlight. There's still that ion tail, not a sodium tail that I've seen reported.
Right.
Now, as the comet was getting close into the sun, temperature profile is changing, new things are getting revealed. They're reporting as it comes out from behind the sun and from spacecraft that have been able to continue seeing it. It's above the plane
Hmm.
of the solar system. So it is behind and above the sun and then coming back around as it continues in towards the disk of the solar system. And it has begun to have significant green light, and that's actually coming from copper in the comet. And copper is, again, something perfectly normal. This is just atoms getting happy, exciting their electrons. Those electrons come back down. They release light, and in this case, the light they're releasing is blue.
Right. But my understanding as well is that when you see it from a spectroscopy perspective,
Yes.
you're looking at the color that's coming from the comet, and is the light predominantly moving into the reddish end of the spectrum and the bluish end of the spectrum. And astronomers will do spectroscopy on an asteroid, and they'll say this is a bluer asteroid, that is a redder asteroid. And if you look at the two asteroids, like, I can't tell the difference. But to astronomers, it's more about like what colors of reflected light are coming off of this object. And it is going to be subtly towards the blue or subtly towards the red. And
This is
part of
not
this comes
subtle.
well, but part of this is coming from the composition of the coma. If it's more dust dominated, then you're getting things that are pushing a little bit more into the red, and if it's more gas dominated, sublimated volatiles, then it's going to be a little bit more blue.
So this is one of those topics where nothing is clean. Literally, it's covered
Yeah.
in dust. Nothing is
Yes.
clean. So you have the black body radiation, which is a continuum of color at all the different colors. That was a stupid statement. And that will shift slightly back and forth depending on how light is getting scattered, how it's getting reflected,
Yeah.
and temperatures. Then on top of it, you have emission lines. And the emission lines are like, and right here, we are now going to pick something. Sodium is something that sometimes gets picked by these, like I mentioned before, in which case
Mhm.
you're adding a spike of
Cyanide.
red. Yeah.
Yeah.
Yeah. And so these are suddenly emission lines. And in cities, we can see how, like, flying over a city will appear super yellow because of all of the compressed sodium lights. That is just one specific color that's getting injected on top of all the other colors from everything else going on in the city. Well, comets have this black body, the scattered light, and emission lines all adding up together to produce their colors.
And what does the future hold for the tail of the comet? What makes it go away in the end?
So it depends on the comet. The short-term answer is as that sucker moves further and further out away from the sun. It was closest to the sun on October 30th. As it moves further and further away from the sun, it is going to cool off. All of the awesome sublimation that's currently taking place is going to stop. It's going to become a smaller solid object. Now, one of the things that is interesting is the perspective we're going to have on this. Sorry. Our perspective as it moves away, it's going to be heading almost directly out of our solar system when it's at opposition with the Earth. So it's going to be moving out of the solar system its tail is going to be getting pushed faster than it is moving. So the nucleus is going to be flying into the tail. And we're going to be watching it from behind. Suddenly decided I can't breathe. So we're going to be watching this from behind, and we're just going to see something that's coma is getting smaller and smaller over time, which is a sad perspective, but also just like, this is the comet that was determined it was not going to give people on the Earth a really clear view of what was going on. Someone has to be the tail end of the pretty view or terrible view end of the Gaussian distribution. We landed on the tail end, giving us the worst view possible of this particular object.
Yeah. All right. Well, I think hopefully everyone now understands comet tails, and we're ready for that wonderful future, incredible comet that will grace the skies any day now. Right, universe? Thanks, Pamela.
Thank you, Fraser. And thank you to all of our $10 and up patrons out at patreon.com/astronomycast. And this is where Rich is going to insert all their names.
All right. Thanks, Pamela, and we will see you next week.
Bye-bye. There is so much confusion in chat about what are they doing? Why are they here? What is going on?
Yeah.
So
and then they saved.
Yes, and then they saved. We are here because
I'm going to be traveling
on the most amazing trip ever.
Well, we don't know that. We don't know that. It could be.
I want it to be for you.
Of infectious diseases and elephant maulings.
Remember that ice probably came from the tap, and don't get anything with ice in it.
I don't know
Okay.